Alright, let's talk about client-server models. So we toss these terms around a lot, but really we use client-server all the time. Basically a server is what we were developing in that previous set of videos, something that hangs out on a machine and listens for connections, and clients make requests of the server. And you may have multiple clients making requests, and that's really where client-server models come into play most often, is when you have a shared resource. So for example, maybe you have a printer, and on the PC you can open up that printer like a file and send information to it and cause it to print. And if two or more processes wanted to print at the same time and they both opened up the printer and started sending information to it, it would get confusing, right? It would get a mix of information and you'd get, gibberish coming out. So instead of allowing a program that wants to print to simply open the printer, it makes a request to a program called a print server. And the print server takes these requests one at a time, and the print server is the only thing that actually talks to the printer. So somebody says, hey, I want to print something. They open up a communication with the print server. They start sending it the information it wants to print. At the same time, another client, another program wants to print something and connects to the server. It's going to hold that request until it's received this first client's request, gotten all the information that it needs, opened up the printer, sent the information to it, gets confirmation that the print is finished, and then it will take what the second client had sent and send that to the printer, and so on. So it's a single program that monitors this shared resource, in this case a printer. Same thing happens with network communication. For example, you have a machine that's serving up web pages to the public. If everybody could just come into the machine and say, open this file, open that file, you'd have this crazy amount of file I/O happening in an uncontrolled way. So instead, the machine runs a web server, right, like Apache. And when somebody wants a web page from a machine, instead of going directly to the machine's hard drive and requesting it, you talk to the web server and you say, hey, I want this file called index.html. And the web server knows where that is, knows if people are allowed to see that page, and will take the page and send it out. And multiple clients can connect to that one server and all get processed, and they can get processed simultaneously, but it's being controlled very carefully by this centralized connection point. So that's a web server. We have an SSH server, which runs on machines that you can SSH into. And when you want to connect to a machine, like the Linux server, you make an SSH connection. Well, that's really just opening up a client socket that's talking to a server socket listening on a port 22, and it asks you for your credentials, and you send your credentials in, and it authenticates you, and then allows you to run an interactive process with bash or whatever your shell is, send commands to that shell, take the output of the shell, send it back to you. So this is a very common model, extremely useful, not just because the server can be on a physically different machine, but even if the server is on the same machine as the client, it's a way to centralize the processing of information. Alright, so we've been working on the server side. We've been looking at server sockets, opening a socket with an address, accepting connections, and then mostly using Telnet as a client. If you run a web browser, if you open up Google Chrome, that is another example of a client, right? And when you type an address in the URL and try to go to that address, it creates a client socket that tries to make a connection to a server socket on whatever machine is specified in the URL address. So this is the other part of the equation, is the client side. And so I want to look at a couple of things. First of all, I want to look at, from the perspective of writing Java code, how do we create client-side code? How do we create these sockets and ask them to connect to a server. So we're going to play around with that and write Java code that will connect to a server that's running on our machine. And then I want to look at complications around that. Why, if we just do this by opening up a scanner and a print writer, it's not quite the ideal communication system. So we're going to talk about asynchronous communication, and then I just want to touch on an aspect of how we can have multiple clients talking to a server. So we're going to go through those topics, and that will pretty much do us for looking at the client side of things. Alright, so let's create some client-side code. So I've closed out the server demo. I'm going to start an entirely new Java project. I'll call it client demo, and we'll make a new Java class. We'll put a main method in it, and we'll just call it main. And so let's just jump into it. Socket sock equals new new socket. So what are the constructor options for a socket? We can construct it with an internet address and a port number. That's the version that we're going to use. We're going to specify what machine we want to connect to and what port we're going to look for. So let's do new socket, and we'll go with localhost and port 1201. And we'll need to import, and we'll need to surround by a try-catch. And it's throwing in, possible multiple exceptions. And I'm going to circumvent this. I'm just going to say if we get any exception at all, let's just print a stack trace and return. So, this can throw an exception if localhost isn't known, if it can't connect to that port, and so on. All of those will throw different types of exceptions, but exception here is a superclass of all those particular types of exceptions. So if any exception occurs, this catch block will grab it. Otherwise, when we come down here, we've got our socket constructed. Unfortunately, if I do something with sock down here, I'm going to get an error. And the reason is that my sock is declared inside this try block, so it only exists inside this try block. So I need to declare it outside, and then just assign it a value inside. And it's warning me that when you open a socket, you should close it when you're done. I haven't done that, so it's saying there's a resource leak. Right? It's kind of like a memory leak. We'll deal with that later. Alright, so let's throw in some comments here. We'll open a socket so we can talk to our server. And then we'll get a scanner and a print writer to read from and write to this socket. So scanner SC, print writer PW, we'll import those classes. So we'll construct a new scanner on socket.getInputStream. And print writer equals new print writer socket.getOutputStream. And all of these can throw tries, can throw exceptions also. And I actually called my socket sock, so we'll do that. And this is an output stream. Alright, so these things can throw exceptions. So I'm going to do something that we need to be a little careful doing, because this can be something we abuse, but I'm going to declare my objects up here, and I'm going to put all of this stuff that can throw an exception inside one try-catch block. Alright, so you know, I've said before when we talked about exceptions, you should keep your try-catch blocks as small as possible. But since I'm not really worried about the difference between, you know, can't resolve this host name, can't connect to this socket, something went wrong trying to get an input stream, I'm just putting all three of these statements inside a try block. Now, I don't want to put the whole main program in a try block. That's way too coarse. But constructing the socket, getting the input stream, output stream, creating the scanner and print writer, I'm okay putting all of that inside one try block. So when we get down here, we're ready to go. So while SC has next line, we will print out the next line from the scanner. And line has to be uppercased here. So while there's another line available, we will print it out. And then print writer, print line. We'll say message received, and we'll send a flush, and we'll just continue with that. Alright, and then when we're finished, we'll say sock.close, just to clean up those warnings about resources. And we'll also close our scanner. Let's close the scanner first. And unfortunately, when you close a socket, that can also throw an exception. So we'll put a try-catch block around that. And that's the last thing we're going to do, so we're not going to worry about if that throws an exception. Alright, so this should receive a line from the server, print it out, and then send a message saying message received. And this looks, you know, pretty promising, but there's actually going to be a problem with it. So first of all, if I try to run it right now, I'm going to get an exception, and the exception is connection refused, right? And that happened at line 15 of main, which was right here, because we don't have our client running. Alright, so our server running. So let's go back to our server code, but instead of running it in here, I'm going to run it from the command line. So I'm going to go into Eclipse Workspace, and I'm going to go into Server Demo and Bin, and I'm just going to say Java main. Alright, so this is our client code running, and if I open another window and I telnet localhost 1201, you can see the client response says I got a connection. I can say hello, cool, bye, and then I can close telnet, and it says socket closed. Alright, so I can go ahead and I can run this client, and it's listening for a connection now. And if I run my my client side code, it says I got a connection, right? So we are successfully connecting here with this socket construction to the server code, but nothing's being exchanged, right? Well, why is that? Well, because remember, the server is set up to wait for an incoming message, and we've set this up to also wait for an incoming message, right? Our main loop looks for a line coming in from the server, And so both sides are waiting for an incoming message. And once they receive it, they'll each send a message, but we've got a deadlock situation, right? Each side is waiting for something from the other side, and neither side is going to produce it until it gets what it's waiting for. So we've got a deadlock here. So let me terminate the client, and that will, close the connection on the server side. And let's, instead of reading a line from the server, let's do something different. So we're going to read a line from the user, right, from the person running this program. We're going to send it to the server, and then we're going to receive a line from the server. So I'm going to make a new scanner. So scanner standard in equals new scanner system.in. So we'll use this to read from the user, and I'll say, well, standard in has next line, and now let's write to the server side sc.standardin.nextLine. So a few things going on here. Right? In this one statement, we are reading a line from standard in, right? Because we've got standard in.nextLine, and we're sending that to the server socket by using the print line method on the print writer. And then we'll say pw.flush. So we'll force the output to be sent immediately. And this will work better, so let me go ahead and run the client side, and let me run the server side. And I've got the server side running over here. Let me run the client side here. It's waiting for input from the user, so this is the user on the client side. And let me hit an enter, and you can see that got sent to the server. So the socket received that. But anything else that I type, will get sent to the server, but I'm not seeing those messages coming back from the server, or it was telling me, these things like tell me more with an index in the front. So we're sending information to the server, but we're not receiving information from it. So let me go ahead and stop this, and let's take care of that situation. So read a line from the server. So the server sent, and I will simply use sc.nextLine and just echo out what the server is sending. Now I'm not saying has next line, but this will do what we call block until a line is available. And if something goes wrong, if end of file comes in, like if the server closes, this will throw an exception, right? So normally we don't just call next line unless we've called has next line first, but we're being a little casual in our code here. So let's run the server side, and we'll start the client side. Hello, client is here. And the server received the message, hello, client is here. And the client said, server sent 0, tell me more. I am the client. And server got that message and sent back a message that said, tell me more. And this is weird. Right, so the server received that message, sent back message 2, tell me more. So we're doing successful communication here, right? And if the client terminates, then that has next line call in the server says, hey, no more input available. But if the server terminates, so let's start running hello, cool. So suppose that this server side terminates. Well, we're sitting here waiting for input from the user, so I can say but then after that I'm going to get an exception, and the exception is right here on line 32 when it's calling sc.nextLine. So that's where I mentioned we probably should be doing hasNextLine, which will wait for a message to be available and then return true, or will detect this exact situation, that the connection has been closed, and that it'll return false. Alright, so that's a basic setup of a client-server pair. The part that's not really ideal here is twofold. The first issue is that this is purely, send a message, receive a message, send a message, receive a message. And we'd like to be able to do something more adaptive than that. So let's take a look at asynchronous communication. So here's what our current setup looks like. We have a client sitting here, we have a server. And the client says hello and sends it over here, and the server is waiting for a message. The client says hello, the server receives the message, sends some sort of OK, and then it goes back up here and waits for a new message. The client, meanwhile, sent that hello, and then it waits for a message. And when the server sends OK, it receives the message, prints the message, and then goes back up to the top. Alright, where this hello is, coming from the user. So if we wanted to have a totally general purpose chat program, we could do something like this. Here's the client side. Here's the server side. So read standard in, send to server, read from server, send to standard out, and go back to the top. And the server can do the same thing. So, in our example server code, there was no user interaction. It was simply reading a message and then sending back a fixed response with an integer in the beginning. But a more general case, the server side would also be reading from standard in of another user. User would read standard in, send to the client, and then read from the client, and send to standard out, so that the user on the server side can see the message coming from the client. This works great in theory. It does not work at all in practice, because the first thing that's going to happen is each side's going to read from standard in. And let's say the client says, hello, my name's the client, and the server says, hello, my name's the server. And they hit enter. Okay, the client's going to send that to the server's going to send their message to the client. Each side is waiting for a message to come in, and will receive the message the other person sent and print it out and come back up here. Right? So far so good. Okay, now the client is feeling really chatty and says, hey, it's raining over here, isn't that strange? It's March and it's still raining. I can't believe the weather. And they start typing all these messages and sending them in, right? Well, the first message they type and hit enter, the client code sends that to the server, and then it tries to read from the server. And until a message comes in from the server, all these other things the client is typing are just being buffered up. In other words, until we get back to this read from standard in and send to server, all the following messages the client types don't actually get sent anywhere. They're just being stored. And if the server has, gone away to make coffee, the first message that the client sends never appears, because the server code does not read from the client until it's finished reading from standard in. So this only works if the client sends a message, the server sends a message, the client sends, the server sends, the client sends, the server sends, and you move in this kind of lockstep. Right? And the problem is that when this tries to read from standard in, it can't go beyond that spot until the user types something. And then once the user types something, it will send to the client, and it'll try to read a message from the client. Well, if the client doesn't send anything, the server can't send anything more because it's sitting here trying to read from the client. So there's a better way to do this. We could have two threads on the client side. Thread 1, read standard in, send to server. Thread 2, read from server, send to standard out. And both of these loop forever. And then on the server side, we also have a pair of threads. Thread 1, read from standard in, send to the server, in a loop. Thread 2, send to client. And thread 2, read from client, and send to standard out. And then go back and loop again. Alright, so now we have 4 threads in play. But on the client side, the client can be typing and hitting enter, and each message they type will get sent to the server in turn. And even if the server is not doing anything, if they're in the other room, thread 2 is continually reading from the client, and each time the client sends a message, thread 2 will read it and display it to standard out. So the server does not need to be typing and hitting enter in order to see the messages coming from the client. And similarly, if the server gets chatty and starts typing in a bunch of things and hitting enter and sending 1,000 messages to the client, while the client is sitting there trying to figure out what to type, right, even though the client doesn't hit enter yet, thread 2 is continually reading from the server, and so each time the server's thread 1 sends a message to the client's thread 2 will read that, display it to standard out. So now we have asynchronous communication, right? The client and the server can be doing their own things, and they're not forced to move in lockstep. So that's a much better setup for this, and this is an example of where we can make good use of threading. So we would have, 2 threads on each side, and they would be running independently. Alright, there's one more situation where we're going to take advantage of threading, and that's the question of having multiple connections processed by a single server. Alright, let's take a look at this one last issue. So I can run our server code over here, and let me open a second window, and let me make a telnet connection. And so now I've got a connection going to the server, and I can type messages and I can get responses back and so on. But while that's happening, suppose someone in another session tries to connect to the server. Well, they can get a connection and they can type, but nothing is happening, right? They're not actually interacting with the program that's running on the server side. And that's because the way we wrote the server code, it accepts a connection, and then it starts this loop where it reads a message, sends a message, reads a message, sends a message. And if we had two-way communication going on, same thing, but each side would be reading from standard in, sending a message, and so on and so forth. But while this is happening, if somebody else tries to connect to the server, they can connect, but the program's kind of ignoring what they're typing. And so that's not a very good model, especially if we had something where we wanted multiple people to be able to interact simultaneously. For example, a web server, right? You don't want somebody to have to wait until the person looking at a web page is finished before they can look at a web page. So what we would do normally is, and let me quit out of here. What we would do is, in here, this is the server code, right? We create the socket, we try to accept a connection. Once we accept that connection, we get a socket, right? It's called sock. And then with sock, we open an input stream, we open an output stream, and we go into our main loop. What we could do is have the server, once it accepts a connection, create a new thread. And that new thread takes this socket, creates a scanner, creates a print writer, and then goes into a loop. And meanwhile, the original program goes back to saying accept and waiting for another connection. And then if another connection comes in, the server would go ahead, get the socket, create another thread. That new thread would then go ahead and do communication through that socket to that second client, and the server will be back inside this accept method waiting for a third connection. And so that would be the way we would normally set up a true client-server situation. We'd have the server able to take in a connection request and then create a new thread to deal with it so it can go back to waiting for new connection requests. Alright, so you got lots of cool practice problems to play with these ideas. We'll do that in class, and then we have basically one class left. We're just going to use that to kind of pick up a few topics here and there, including looking at the URL class. So we'll do that next time. Alright, thanks.